we basically swap out the hibernate with the full instance with all the animation and the stuff. All told, 600,000 hibernating objects takes up 24 megabytes of memory at runtime, and the geometry is really just 13 megabytes because it's mostly the same water tower and fire escape. All right, so TLDR in the background, let's review. We use billboards and low poly models in the distance for Brooklyn, Queens, Bronx, New Jersey, you know, all the boroughs. The skybox is an ordinary skybox. Imposters are, as I've said, the high quality imposters stuck on. Those are the hibernates. Everything else is not background. Once again, this is all about fitting the text to the context. This whole notion of hibernates is because Manhattan has the water towers and the antennas and the billboards and those weird fire escapes that you bolt to the side of the building. They're a very specific solution for this very specific product. Oh yeah, specular lighting, forgot about that. So it would have taken 8 gigabytes to put on disk. Our specular model is based on something we call env probes. Env because they're environment maps, and probes because they're locations that you put throughout the city. We build environment maps like anyone does. We go to every one of those probe locations, load up the level, take a picture in all 6 directions, bake it into a cube map. Then when you need to do a reflection, you just look at the cube map instead of actually reflecting. Let's step back a moment and ask, why do we do it this way? Right? If we wanted a reflection, we could just re-render the scene from the point of view of the reflective surface and then glom that onto the surface. The reason that we do environment maps in the industry in general is to speed things up. We do that offline for all the world and then just load that when we need to reflect something. But could we maybe trade a little bit of runtime to get back a lot of disk space? The answer is yes. We decided to calculate our environment maps kind of at runtime. We have 64 of them in memory. It's like a cache. As you're swinging through the city, we ditch the ones that you've left behind. If there's a nearby one that doesn't have an environment map on it yet, every frame where we have spare time, we will pick one face from one probe and render that face. Because we only need to use the background geometry for our environment maps, you know, animating things are not captured in our environment maps, it takes about a millisecond to render one of the faces, so, you know, 6 of them and then at 2 MIPS, it's 12 successive frames to populate an environment map. You'll never notice. And after all that, they take 0 bytes of disk space. Let's talk about animation.
Writing your memoirs? Don't forget the hyphen between spider and man.
Get the chopper ready. I won't be long.
So as you can see, the visual fidelity target for our facial animation is very different from our previous games. On Ratchet, we could get away with using skeletal animation for the faces because that was a deliberate part of the aesthetic, right? We wanted that kind of friendly cartoon look. But on Marvel's Spider-Man, we used facial capture for almost all of our cutscene performances. The thing where you've got the camera and the dots on the actor's face and you record them acting. The bodies and some of the head are skeletal animation, like the jaw and the eyelids and stuff like that. But the really fine detail, like the movement of the muscles and the creases and the wrinkles in the skin, it's very hard to do that just with skeletal animation. So for that, we decided to use morphs, and to get it right, we needed between 600 and 800 morphs per character, which is a lot of morphs to composite at runtime. So we decided to do all the morphs offline and then just stream verts at runtime. We'll do the joints, but then we'll like divert offsets from that. Ended up actually being less than 2 megabytes a second, so we thought it was crazy talk at first, but it ended up being okay. To get there, we worked with a couple of partners. 3 Lateral scanned our actors for us, very high quality textures, really nice models, rigged the faces for us with 240 joints, and in the case of Peter Parker, 620 blend shapes. So there's the joints going, there's the blend shapes for the really fine stuff, and then you put them together, you can get basically any expression you need out of them. Cubic Motion then took the recorded performances and worked out what combination of joints and morphs and so on would get the animated face to the same position as the actor's face. So from that, we can figure out how much bandwidth we'll consume to stream these faces. Every one of our faces is about 18,000 verts. I'm not counting the bodies and the hair and the whatnot, just the face that we're doing the vert streaming on. So from that, we can work out our bandwidth per face metric. Peter Parker's face, 18,375 verts exactly. So of course, we're going to store 3 vectors per vert, positioned in the normal for the lighting. 3 floats per vector at 30 frames a second is 20 megabytes a second. How about no? Turns out skin does not move more than about a centimeter from your face while you're still alive. So we can get away with using fixed point notation for them, 10 bits for every component, 30 bits per vector. Also, the normal and the tangent, right? Like, what if I told you there was something called a cross product that you could use to work at the normals just from the positions? Why, let's step back, like, why do we store normals and tangents in meshes and textures at all? It's to save on runtimes, because calculating all that stuff would be redundant. Except in this case, the bandwidth was really the scarce thing, and we actually had a lot of CPU time left over because there's not a lot of sim going on during a cutscene. You're not swinging the city, nobody's AIing at you. So we ended up just really as a compression tactic, streaming just the positions and doing the normals and tangents at runtime. That gets us down to 2 megabytes a second with careful arrangement. LZ gets us down to half a meg per second per face. Here's the format. Every frame in a streamed animation first has all the joint positions for all the characters, followed by all the vert positions for all the characters that vert stream. We do the structure of arrays thing, so that's like all the X components for everyone and all the Y components for every vector and then all the Z components, because it compresses better that way. Also, we delta compress these things, so for frame 2, every vert position, it's not the absolute position, it is the difference from its position in frame 1, because most verts actually don't move from frame to frame, which means we have these long runs of zeros, which LZ4 eats up. Obviously, this makes scrubbing really annoying, but the player doesn't scrub. Oh, also, like, the problem with this is that there's a zillion places for things to go wrong. All you need is a single off by 1 error, and it's just this total horror show of, like, joints are verts and verts are joints. Also, if you have like a black spot on a character's face, what's going on there, right? Is it missing? Is it missing from the mesh? Is it the wrong position? Is the lighting wrong? I'm not going to talk over this. Yeah, so somewhat belatedly, we realized we needed a tool where we could render just like one streamed face in an app of its own and then point. Why did I do this? Point at a single polygon and say, you poly, what's all the math that made you? Once again, we revisited our speed and space trade-offs. A lot of the things that we had done in cinematics previously were based on the assumption that CPU was scarce and disk space was plentiful. That became not the case on this project, and especially not for bandwidth. So we realized we could actually spend more CPU to make up the space. Let's talk about populating the city.
Please, don't ask me to do the hand thing.
Can I get an autograph?
Can I get a selfie?
All right, our original plan for pedestrians is that they were just window dressing, non-interactive. You would just see them from up above, so we could get away with some simplifications. Of course, here's the problem. Yeah, so in 2015, we realized that was not going to fly. The number of pedestrians we began with was not enough to fill out the streets. It made them look really weird when they weren't responsive to the world. They needed to look diverse because that's kind of New York's thing. And they needed to interact with Spider-Man when you were down there. So our original prototype just had actual AIs, bots that we drove around the world for pedestrians. And we can run 30 of those at once. And we needed a whole lot more than 30. After a whole bunch of chicanery, we got it up to about usually more than 1,000 pedestrians on screen at a time. I'm going to spare you the details on that one because it's been discussed at GDC before many times. 2015, apparently the year of the crowd at GDC, so there's a bunch of great talks. What? All right. Someone say something? So you can go dig those up. The one thing I do want to show you is how aggressively we LOD. So in this video, I've left the LOD pivot back there, and I'm pulling the debug camera without updating anything. We stop animating the pedestrians the moment they're off camera to save on skinning. Also, when you get beyond a certain distance, they are not peds at all. They're just like these totally unanimated, unskinned, creepy sack people things. Because they're like 4 pixels tall, you'll never see the difference, right? We can save all the time on skinning. It's just enough movement so that they don't look like they're static. We could have probably used billboards. Also, we realized kind of late in 2017 that window dressing isn't enough. If the peds aren't interactive, you're not they don't invite you to spend time on street level and see all the cool stuff we put down there, and it seems really robotic and weird if they don't acknowledge you. And also people just enjoy messing with the peds and seeing them interact. So late in the game, we came up with a couple of interactions for them to do. The low intensity ones were simple, right? You just go down there and they would do a canned behavior, take pictures of you, call mom, wave, whatever. Also, we noticed it was kind of weird if you hit the punch button while facing a pedestrian and took a roundhouse at their face and they didn't react. So we just replaced the animation. Kind of became a thing. We also came up with some more high-intensity interactions. Every so often, we body snatch a pedestrian and turn them into a full AI. Then they perform one of a few canned interactions when you walk up to them and hit the triangle button. In some cases, it's a synchronized animation. In some cases, they'll point out like crimes or collectibles for you. In some cases, they're in cahoots with one of the villains, and you get close and like, "Ha! I work for Fisk. You're going down, Spider-Man," just to give you a little bit of surprise and variety on the streets. So looking back, it's the classic GDC story. We should have started on this sooner. No, we did. We had this from the beginning. We knew that we needed this. We just had the wrong prototype. And once we realized we needed more, we just kept iterating on that one prototype rather than going back and rebuilding it from the beginning. So we had like this full AI thing, and then we just kind of like added those non-skin things on top of it. We never went back and built a system from the ground up that had better concurrency, a real crowd sim. We would have liked more unique interactions. Really, the lesson I want to communicate here is if you put a human being in the game, the player's going to try to interact with them, and you just can't fool yourself that they won't. One last thing that I want to talk about before we get into Q&A is to talk about photo mode. And the most important thing I can say about photo mode is that programmers undervalue it. But the success of photo mode is not a tech story, it is a social story. It was a story of basically like Stone Soup, that folktale where everybody comes and contributes, and it made a much bigger difference than we suspected at the beginning. So we began working on photo mode about 5 months before ship date, but we did a lot of work in those 5 months. And our original plan was something very simple, just basically so we could claim that we had done photo mode. Basic 3D camera, some controls, rotate the camera around, and some stickers. All right, well, where are we getting the stickers from? So we had the little social media display in the pause menu. So we just grabbed the textures from that and used those as stickers. And this was a stroke of luck because those things have a specific aesthetic that immediately encouraged other texture artists to come along and start contributing their own stuff, other characters in the books. And it's a comic book, right? We can start throwing in the onomatopoeia and some speech bubbles. And what if you take, bear with me, what if you take a sticker, but instead of it being opaque in the middle and transparent everywhere else, what if it's transparent in the middle and opaque everywhere else? And that's where frames came from. Someone looked at that one movie poster from that one movie with a superhero taking a selfie and said, how about we have selfies? Yeah, selfie mode is a thing. And that's when people really started to see themselves in the product. Because people, when we were even developing, just loved taking selfies of themselves with the content that they had made and with bugs that they encountered. And when people were doing that on the team, they started to see opportunities for themselves to contribute. Like, an animator said, I can make Spider-Man make funny faces. And a lighter said, it's not that hard to put a light on the locator and get a selfie light. And a shader artist said, yeah, you know, with just some simple color lookup tables, I can totally make a whole bunch of photo filters. Behind the scenes, it's really simple. We just duck out the gameplay character, replace it with the cinematic character, drive an aim matrix with the thumbsticks, have different poses on the cinematic character depending on whether you were standing or perching or running. The camera's attached to the locator, there's no fancy... Okay, I mostly just wanted to show you this video. But it turned out to be a huge promotional win for us to have this in from day one. Photo mode is an intrinsically creative thing, right? People want to express themselves in our game and then immediately to share it with their friends. And the sharing it with their friends was a really nice thing. And if we had done photo mode as like a DLC weeks later, it would have been cool. Like, people would have gone on Twitter and said, look at this photo mode thing from the game from last month. But for us, because we had it in day one, it hit right at the peak of the hype train. Like right as our advertising spend went in, this stuff was all over Twitter. So it made a huge difference for our launch momentum. We were kind of nervous about photo mode at first because we thought people would take pictures that made the game look bad. But it's not a problem. One, people like the silly photos, and two, no one cares. So here's the morals. Simple is really good, still to this day. Fit the tech to the context. I was talking about the context of our specific engine, but really anything you're doing, reevaluate the specific game that you're making and build the tech around that. Right? That's why we have programmers on teams. Nothing has to be completely generic. Continually revisit the speed and space trade-offs. We had to think over all the choices that we had made on previous projects for the specific context of a city that has everything that Manhattan does. And if there is no fun, then what is even the point, right? We are toy makers for a living. If you're not having at least a little bit of fun making the game, you're not going to find creative ways to contribute it, and you're going to have a hard time putting fun into the game. So I am the one up here talking, but this talk was a team effort, so here's everyone who contributed. Mostly I just punched it into PowerPoint. I really want to thank Sony and Marvel for letting us play with their toys and make this game, and I super duper want to thank my talk advisor, Andreas, who carried me across the finish line and the start line, and he just carried me. And thanks to everybody at Insomniac who actually made the game that I'm talking about. Oh yeah, we're hiring. Please apply. All right. Appendix. Appendix. For those of you watching on video, get your pause button ready. Here's the numbers. Bam. All right, Q&A. He'll be fine. You can line up while this is going on. Like, I put these in for while people were milling around.
All right, I actually have something.
All right, thank you.
What's the funniest glitch, like the things that are displayed here, that you personally have encountered in this game?
I put them up there.
Which of them do you like the most?
Oh, the one where the guy gets like punted over the girders into the distance. It gets me every time. You know, it's like a football goal. It's good. It's good. Yeah. Also, we got a Brooklyn Bridge, but no Brooklyn. Yeah, we were off by 1 on the model index. All right, now seriously.
I have another question.
Yeah, ask a question.
So as the second clip demonstrated, through the game there are a lot of characters that get knocked off buildings. I wondered if you wanted to... I expect that being able to show Spider-Man wasn't just knocking people hundreds of feet to their death was part of the design. Do you want to talk about some of the challenges that came about trying to save those people?
Oh yeah, so the question is, Spider-Man knocks a bunch of people off the buildings. How do we keep them from dying? The challenge, basically the reason that they don't die is Spider-Man doesn't kill people gratuitously. And to make them not die, we simply just do a rake, like when they're going over, we do raycasts in all directions, find the nearest vertical surface, and just stick them to that. It's really simple.
Thanks.
Oh, sorry.
Hi. First, thanks for the great talk. On the slide that you mentioned the vertices, auto compression, and that you needed specific tools. Would you be able to talk a bit more about those tools and what was needed, what was really interesting in that sense?
Oh, the debug tool?
Yes.
Okay, so we have a notion of a viewer app which loads basically just the engine but none of the gameplay. It's just like enough to view models in game. And we can turn a bunch of stuff on and off in that to test specific engine features. So essentially what we did there is we just can pick a single animation, stream the animation, a whole bunch of diagnostics on all the math that's going into making the face. From that, it's really just, we have a mouse selector, you can click a polygon, and then it just freezes the stream, and then just shows all the calculations that happen from the decompression, through the lighting, through the normals, through the tangents, to make that poly happen.
Thank you.
Yep.
Hi. So you mentioned about the feeding tech to context, and right now, like game engines like Unity, Unreal are used for several things. But I was wondering if you have any thoughts on when it's a good trade-off to start investing in your own technology for like your own game engine, and like taking like when is a good time to start investing in that?
The question is, when is it a good time to start investing in your own engine? well, that is a philosophical question that I'm not sure I can answer for you. I mean, the short of it is when you have enough of a space on your payroll to write your own engine, and when you know what you need from your engine, right? A very small engine is a lot easier to build than a big one if you're making a very specific game. I guess it fits the text to the context again. I don't know if I have an answer for you on that one. I'm sorry.
Yeah, no worries. Thanks.
All right, you?
Because it's a platform exclusive and very much 100% likely to remain so, how beneficial was it to know that you were just using that platform's profiling tools for optimization? And is that different from other projects?
Okay, it is super useful when you're optimizing to know that you have a fixed platform. That is like the advantage of consoles over developing on PC. Also, both of the console makers have really good profiling tools. They're different, but they're both awesome in their own ways. So, I mean, I guess that's the answer, is relying on the tools that the platform maker gave us was absolutely fine because they were very good. Did I answer your question sufficiently?
I think so. Okay. Thank you.
So you are a studio making multiple games at the same time, but you fit your engine completely to the game. So how does that work out? Because then you either strip out everything for the next game, or just the game where you're prototyping on has to just live with what you do?
So that is an excellent question. We have sort of tiers, right? We have a core engine, we have the gameplay code, and then we have this notion of like a shared library, which is the thing that sits in the middle. We work on engine features and they just grow by accretion, so when an engine feature becomes available to one game, it becomes available to all of them. So the core stuff like the Hibernate renders are actually going to end up in some of the other games just because it's conveniently there. We do need to be very cautious about when we release the engine to which projects so that we don't inadvertently break the projects, but we do make sure that the same engine and the same tools go out to all the projects eventually, so that they're on the same.
And because the streaming system is probably very specific, probably used by the other things. So.
Yes, I mean, so if we mark the zones that they load when you're within a geographic space, then it's like streaming, like I've shown you here. If you mark them so that they're loaded by script, it's the exact same thing. We're using the exact same streaming logic. It's not happening all the time. And you may notice that our games stream more and more as this technology becomes conveniently available to every project.
Another small question is that you have everything set up that it just fits with the tiles and things like that. Did the game designers all of a sudden want to like put a cutscene on the other side of the world and then you just have to stream and it doesn't fit in memory, or you were just like very strict and it's not possible?
So I addressed this in the Sunset Overdrive talk. The gist of it is we have to be careful not to set cutscenes in faraway locations unless we can load in like a very small cyclorama behind them, but like basically load in a set quickly enough for that cutscene to work. However, once we're in that little thing with the narrow camera, right, we can hide all kinds of ills while we're streaming the world around it.
And sorry, one last. So you deduplicate MIPS and everything,
yep.
And you put that into things. When you, for example, make a texture change, what is the iteration time then? Because you need to rebake everything?
To bake an individual texture is seconds.
Yeah, but you need to rebake then all the, basically, tiles loading that data?
Oh, I see what you're saying. So we have two ways of loading assets basically that we use during development. The stuff that I showed you is like the final package version when we're trying to optimize it.
Yep.
We can also loose load files. In fact, we have a thing where, for the most part, when you're editing assets on your PC, the PC is actually running a little service, a little web server, that when the game goes to load assets, it actually hits that web server on your PC. The reason we do that is so that if you change an asset, it updates in the game immediately.
Okay, just one. Thank you.
All right, thank you.
Excellent talk, excellent game,
right.
But I have to ask, why did you de-res the puddle?
All right, so if you don't know what he's talking about, there was a scene that we showed in our E3 trailer that had this big old puddle in it, and then when we showed that same scene in the final trailer, that puddle was like not there, and the internet lost its mind because they thought we had taken out reflective puddles for performance reasons. So we gave this really confused answer then because nobody actually knew why this. I had to do an investigation to figure it out. I talked to like 14 people and got a whole bunch of different answers, but I finally got to the bottom of it. Are you ready? We switched from hand painting them to procedurally putting them in. It's just too much of a pain to paint all the puddles in. That's it. It's a different procedural seed. Now you can have all the puddles you want. Anything else? We got 2 more questions, 2 minutes for Q&A. I'll talk about one thing that I wanted to talk about. Blah, 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 blah. Oh yeah, so traffic. We had a really simple traffic system. They're basically pedestrians with wheels. So in our system, like we don't have any sort of global navigation, so every car just looks immediately ahead of itself and then stops if something is in the way, and pedestrians don't look before crossing the street. So the realism is amazing. We have at any given time about 180 cars, driving, of which 25 are actually moving and the rest are stuck in traffic. So again, realism. And parking is really hard in Manhattan. That's it. Oh, sorry.
Can you watch the blooper reel again?
Only if there's no other questions. We'll do it while people are coming up if they have any other questions. Oh, come on.
This is a super naive question, but I'm really curious.
Yep.
Like you said that you guys did this awesome streaming tech for this, early on in production, where he gets into the interior and everything is seamless, everything is brilliant. It took a whole month, calendar month, I assume, of development time. It seems like with all that technology you built, why did it take so long?
So it's essentially to do all the nitty-gritty. The question is, why did it take so long to set up the interior transition in the Fisk base? The answer, it's not like a tech thing. It's just the content of like framing the cinematic carefully and being really careful about the budgets, because we're still limited by how much we can get off the disk when we're loading stuff in, and balancing the things and making the art the right size so we can load it in. Long story short, it's just a continual balancing act, and spinning that plate was a bit of a pain. Where we're going, we don't need roads. See ya. Oh, there's one more. Yep.
So when you were dealing with moving out and like de-resing the people so they didn't have really nice textures on them, what did you have to do for cars? Did you also do that, since the cars do look really nice in game?
Yes, so the cars LOD less than the pedestrians do, simply because we didn't have the programmer resources to do it quite as much. It's okay though, because the cars aren't skinned to the same level and they're just less poly. They do disappear. The one thing that they do is like the moment they're out of view and they go around a corner, we just like move them back in from someplace else. Oh, one other thing with the cars is, so an actual car chase would obviously not be possible in Manhattan. You'd get like 3 blocks. Yeah. So whenever there's a car chase in progress, we actually look ahead on the spline where the car chase goes and just despawn all the cars there. The chase can actually happen.
Okay, so when the car goes around a corner, you just kind of like remove it, so like you don't have to worry about it moving around and all that? Okay, thanks.
Just a quick question. When you're looking at Manhattan from far away, are you simulating any kind of traffic or pedestrian? Like if I'm looking right down the road all the way across like multiple streaming levels?
Okay, so the question is, how much of the traffic and the peds do we stream from far away? The pedestrians, like I showed you, it's the little sack people within a few blocks away. The traffic is simulating out as far as you can see, and that's one of the reasons why we didn't LOD the cars down so much.
So you're simulating like the whole city, basically?
Well, no, we're simulating like the whole street that you can see ahead of you, right? If something is obscured into the sides, like we're not simulating the traffic lit to the left and right when we're doing that. As soon as you turn, those cars come into existence.
Thank you very much.
Everyone. So I'm Dave Churchill. Today I'll be talking about the hierarchical portfolio search system that I created to make the AI for Prismata. It's a complex name, but that was just to sell the paper. It's really simple, I promise. So I made this game with Lunark Studios, but now I'm a faculty member in the computer science department at Memorial University in Newfoundland, which is the easternmost rock in North America. So, Prismata. Prismata is a hybrid strategy game that we've been working on. 2-player game, alternating turns. You can think of it as sort of Hearthstone or Magic the Gathering meets StarCraft. So it's a card game without cards, And it's a real-time strategy game without the real time, so it's a really interesting strategic game. So before I get into the AI system for the game, I'm going to explain just some basic properties about the game. So the game has two players. Here we have the AI up on the top, and the player, who's me, down on the bottom. And it's alternating turns. So that means I'll take my complete turn, and then the opponent will take their complete turn. So on the bottom half of the screen, you see my units, player 1's units. And on the top half of the screen, you see player 2's units. Okay? Also, each player has a certain number of resources. So there are 5 different resources in the game. Each of these can purchase a certain number of units, so certain technologies can only be purchased by certain resources. Each player has their own resource pool. Many of your units can be clicked to activate abilities. So for example here, I have the drone unit, which is sort of a worker type unit with an RTS flavor. And when I click on the drone unit, I get some gold. So each drone click gives me a gold, and each unit can only be clicked once per turn. So once I have some resources, you see over here on the left side is some purchasable units. So unlike most strategy card games, there's no hands or decks in Prismata.
I made a game called The First Tree, and as you can see from the title, it was no time, no budget, no problem, but it's kind of I don't know why I wrote that, because there was a lot of problems in finishing my game. There was a lot of sacrifices, but it worked out. It was successful, and that's with you guys today. So if you don't know what it is, The First Tree, oh, that should be playing. So The First Tree is a third-person exploration game about a fox looking for her missing cubs, and also about a second parallel story being told about a son reconnecting with his father in Alaska. And this was a project I made to get out these emotions of me losing my own father to a heart attack early in life, or in 2010. And so I made this, and I wanted to share that story with people. And for a hobbyist project, it did a little better than I thought. I was able to show it at the Smithsonian American Art Museum, show it at PAX West, and it was cool to let that little story gain traction with people. And maybe you're thinking that's not a super unique story for an indie game success story. But what usually gets people's attention is that I finished the game while working full-time as a technical artist at a VR company called The Void. I was raising 2 kids and making sure that my partner, Elise, had time for her art career. And then I made the game without very much money at all. So when the game launched on Steam, September 14th, 2017, it cost me $10,000 to make, and that includes my website, conventions, music, everything. The time was about 18 months of nights and weekends, or about 1,000 hours. And its first year, it made $150,000. That was my gross revenue. And consoles came a year later. I was able to use those funds to pay for a console port with the assistance of Duke Games. And that made $150,000 in its first month on all 3 consoles. So yeah, it was awesome. It was like a dream come true. And a lot of people ask me, how did you do that with so little time and money? What you probably heard about is how the game had a lot of Reddit traction. And I got good at submitting this content, these GIFs, and seeing how they would perform. And so when on launch day, I could have the marketing dream come true and then get on the front page of Reddit, which got me about 3 million views on that GIF and 200,000 Steam page visits. And then on consoles, in November 2018, when the console release came out, I was able to do it again. And so why did it do so well? That's a question I ask myself a lot. And I would say luck did have a big part to it, but it's not the entire answer. The facts are that I submitted a lot of GIFs everywhere, and it was consistent posting over 18 months. Some of the posts did great, some of them didn't, and it basically comes down to how do you eat an elephant, or a fox in this case. You eat it one bite at a time. So those years of experimenting that taught me what works. also taught me a lot is that I made another game before the first tree, just to challenge myself, because I come from a film and design background. I'm not much of a coder at all. So I made my first game. It was a first-person exploration game called Home is Where One Starts. And I used mostly just Unity assets and Playmaker. And through a lot of bundles and extreme discount, I was able to make $15,000. And it also taught me what not to do when releasing your first indie game. I launched at midnight because I was like, oh, that's what movies do. They do a midnight premiere. I'll try that. I changed my launch date last minute for some reason. I had no one covered the game on day one. I had no email list, only 200 Twitter followers. And there was a lot of popularly requested features for Steam, like trading cards and subtitles that I waited to patch in later. So I've distilled what I learned from that first experience into my launch plan for the first tree. And how would I sum up like my launch plan for the first tree? The best thing is, I would say, is it's low time, high impact strategies. I'm not sure that's like that won't be taught in business schools anytime soon. But what it just means to me is like, you don't have a lot of time, you need to be as productive as possible and try to like take that risk of making a high impact, even if it's a little more risky. So the rest of my talk's divided into two sections: how I developed the game with little time and money, and how I marketed it. So first, just finding that time to finish your game. That's hard, especially if you're a parent, like how exhausting life can be. So this was kind of our rough plan with me and my wife Elise. I'd work full time, and then also Elise needed time for her art career. So we hired neighborhood teens to see if they could watch our kids for about $7 an hour. So I'd get home from work 45 minutes, and then get the quality time together, and then at the end of the night, probably fit in 2 hours of development. And that gave me about 10 hours a week. And usually, there were sacrifices there. I wish I've played more of all of your guys' indie games, but I definitely haven't. I didn't play many games or watch many movies. Usually, to get quality time with Elise, we'd watch a people getting hurt on YouTube compilation video at the end of the night. And at The Void, I don't think you need a game development day job to make your passion project come to life. I will say though, there is some crossover benefit. I remember, again, I'm not much of a programmer, but I was learning about singletons the first time, and we were using that in a project at The Void. And just learning about that helped me fix a Steamworks initialization bug that had caused me a ton of grief. So that's cool when that stuff crosses over, but I don't know if it's necessarily required. Okay, so you found the time. Now, what do you do with that? Now, this is something I would even say I used to be a little embarrassed about this, but I am now a huge believer in using publicly available assets that you can license. And prototyping, it's great, but just using it as a springboard to save yourself valuable time and creating it, revising it and changing it to add your own creative twist, that's the reason my game was finished. That's why my game released, is because of these resources. I probably could have made a lot of this stuff myself, but I estimated it saved me roughly 600 hours. And while I did have to spend a little bit of money, it was nothing compared to hiring a full-time composer or even voice actors. I did the voice acting. I pressured my wife to do the voice acting. She did great. I wish I didn't do that. So maybe we should have hired an actor, but you just gotta do what's best for you. This is an example of how I tried to make these, this beautiful environment pack by Michael Gustafson, try to make it my own. And so, yeah, I would even say it helped other artists too when the game was successful in the marketing. All the music was done by a composer named Josh Kramer, and his music is gorgeous, and it was only $30 to $50 a song. And so when the game did well, we were able to kind of form a partnership and help get his music out there more. So this is the third thing about finishing your game, is I tried to challenge myself never to have a 0% day. I have this gift running because I love UX and UI design. And I remember I was so burnt out, I did not want to work on the game anymore, but I love doing this stuff. So my thought was, if you can just aim for a 1% day and get those small wins, then it will encourage you to do the harder stuff that you hate to do. So whether it was just answering an email or doing a small color change, I tried to work on my game every single day. So what are the cons of doing these low time, high impact strategies for development? Well, I did have to compromise my vision a little bit. Like, I'm inspired by the games like Firewatch and Journey, but of course it couldn't be like that. It was just